Thought I was making a video and I was just taking pictures. Mercy, mercy, mercy. Here's part 3 of trigonometry. So part 1, if you have two sides, you can use Pythagoras. Part 2, if you have two angles, you can find the third by knowing that the angles are supplementary, add up to 180 degrees. Number 3 is they figured out a long time ago. They have pictures of the Egyptians using this theory. I believe it goes back to the Greeks, maybe before that. But they found out that if you have triangles with the same angle measures, and it's a right triangle, same measures, right triangle, that the ratio of sides is always the same no matter how big or how small it is. So for example, a 30, 60, 90. The side opposite over the hypotenuse is always 1 over 2. So 2 over 4 is the same as a half. If I had, notice this is bigger, but 5 over 10 is 1 over 2. So the hypotenuse is always, oh, by the way, the side opposite the right angle is called the hypotenuse. The other two sides are called legs. Now, if a side is opposite the smaller angle, it has to be the smaller side. So the side opposite the 30 has to be smaller than the 60 and the 90. And if you think about it, if I have an angle, watch what happens to this opposite side, this side here, if you connected them, as the angle gets bigger, the side gets bigger. So in a triangle, the side opposite the biggest angle will be the biggest side. So the hypotenuse has to be the biggest side because 90 has to be the biggest angle. If it's 180, some interior, then this has to be the biggest because you can't have another 90 or bigger because it's bigger than 180 then. So the hypotenuse is always the biggest, and then the side opposite the smallest side angle will be the small side, or the small side is always opposite the smallest angle. But they figured out this ratio is always true. So the same formula or same angle measures, you'll have the same ratios. So they actually came up with the 6 ratios that happens in a triangle. So this over this, 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 this over this. There's 6 of them. And the 6 of them they've named. Now, I think they named them wrong, but who am I? You have sine, which they abbreviated sin, but that's okay, we can pray. Now, the trig function, it's called, always has to be compared to an angle. So if I said this over this, they had to compare it. Is it this angle we're talking about or this angle we're talking about? So what they did is they gave it a Greek letter for now. And the sine is always opposite side over the hypotenuse. So then we have cosine, which is COS, abbreviated, angle, is always the side that touches the angle, adjacent they call it. So if I'm talking about this angle, A would be the adjacent side because it touches it and it's not the hypotenuse. This side doesn't touch it, so that's the opposite side. Then we have tangent. Now I've seen in puzzles, tangent, they'll say a mathematical formula of that's been out in the sun. Well, oh, that's horrible. And they abbreviated tan and a Greek letter. Oh, I'm sorry, I didn't finish cosine. It's over hypotenuse. And I'm going to start abbreviating this because I'm getting tired. So, and then we have tangent is opposite over the adjacent. Now, for many years, we only really dealt with these 3 because the memory of a calculator couldn't hold much more. So you would use the reciprocals to figure out the other one, the reciprocal button. But now with Desmos and the high level ones, they have all 6. So the reciprocal of sine is cosecant. Now again, I didn't name these. And that is CSC. And the reciprocal of opposite over hypotenuse is hypotenuse over opposite. So if I find sine and take the reciprocal, that's cosecant. Cosine. The reciprocal of that is secant. Now again, I didn't name these. I think they should have done well, never mind. I just think this gets a little confusing. But the reciprocal of cosine, it'd be hypotenuse over adjacent. Now this is the only one I think they named right. Cotangent, which is COT, which is the reciprocal of tangent, which is adjacent over opposite. So if I said, what's the sine of angle A? You would find angle A and then go opposite over hypotenuse, which is the ratio A to C. If I said, what's the cosine of B? You would say, okay, angle B, adjacent. That's the side that touches the angle, that's not the hypotenuse, over the hypotenuse. So that would be A over C. So notice the complementary angles for cosine and sine have the same ratio. Now, notice we never use angle C when doing the basic trig functions, because if I said sine, well, opposite would be C over a hypotenuse, which is C, which that doesn't make sense. So it's the trig functions of the complementary angles. So right now, what's tangent of A? Well, tangent is opposite over adjacent. Opposite would be A. Adjacent is the leg that touches it, but is not the hypotenuse, so it'd be B. So it'd be A over B. Now, what is secant? Oops. Now, the way I remember this, secant looks like a backwards cosine. That's how I remember it. So what's secant of A? I'm making a mess here. Well, A is here. Secant is hypotenuse over adjacent, the reciprocal cosine. So it'd be C over adjacent is B. So we're actually going to use this on a calculator tomorrow, not today, because it's been a pretty long lesson today. All I want you to do today is to memorize these 6 trig functions. So sine is opposite over hypotenuse, cosine adjacent over hypotenuse, tangent opposite over adjacent. Now, for years they had good land, what is wrong with me? A phrase called SOHCAHTOA. Now, I never liked this because my grandmother used to come in and soak her feet, and her toes kind of went out at different angles. Ooh, I'm imagining now, what'd you do to me? And SOHCAHTOA, oh, she's soaking her toes. Oh, grandma, oh. But they have sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. And tangent is opposite over adjacent. So if that can help you, then also remember the reciprocals. So cotangent's the reciprocal of tangent. So if this is opposite over adjacent, it's adjacent over opposite. And then cosine secant. So cosine's adjacent over hypotenuse, hypotenuse over adjacent. So real quick, what is cosine of angle A? You'd say, well, here's angle A. A is cosine is adjacent, which would be B, over hypotenuse, which is C. So what is cotangent of B? Well, here's B. Cotangent is adjacent over opposite. Hypotenuse can never be adjacent. It's the hypotenuse. So it'd be A over B. Woo-hoo. Adjacent over hypotenuse. Okie doke. So anyways, I hope you're having a good day. Again, the homework is just remember these 6. We'll figure out how to use them tomorrow. So these 6. If you want to do SOHCAHTOA, that's fine with me. But remember these 6. Maybe tomorrow morning at 8 o'clock I'll show up at your house and give you a pop quiz. Oh, better have breakfast ready. No, I won't. That was another April Fool's. April Fool's. I'll see you tomorrow. Remember these 6. These 6. Remember these 6.